The Wehrmacht Logistics Intelligence Briefing that reached General Georg Thomas's Economic Warfare Division in Berlin during April 1945 contained fuel supply statistics that seemed to mock the fundamental laws of petroleum production and wartime resource management. The classified document claimed that American refineries had delivered over 5 billion gallons of aviation and motor fuel to Allied forces since Pearl Harbor, suggesting production capabilities that violated every German assumption about petroleum manufacturing and wartime fuel supply limitations. This is economic propaganda designed to demoralize our fuel-starved forces, General Thomas declared to his logistics staff, studying reconnaissance photographs of American refineries that showed fuel production operations spanning entire industrial complexes. Petroleum refining requires complex chemical processes that cannot be scaled to produce billions of gallons. No nation possesses the refining capacity to manufacture such astronomical fuel quantities. These Americans must be including civilian gasoline and heating oil in their military fuel statistics. These were experienced German logistics officers who understood fuel production through decades of petroleum engineering and strategic resource management that had created Europe's most sophisticated synthetic fuel programs through systematic precision and technological innovation. The concept of mass-produced petroleum seemed to violate fundamental principles of fuel manufacturing that demanded careful chemical processes over volume production. They could not fathom they were witnessing the greatest fuel production achievement in petroleum history, or that American refineries would demonstrate how democratic industrial organization could manufacture petroleum products at rates that would overwhelm German fuel scarcity through unprecedented supply abundance that rendered individual fuel conservation strategically irrelevant against unlimited American energy resources. If you want to discover more incredible stories of how American industrial supremacy revolutionized modern warfare, make sure to subscribe to our channel and hit that notification bell. General Georg Thomas stood within the Lohna synthetic fuel facility in occupied Germany, embodying German confidence in fuel efficiency through innovative petroleum technology and systematic resource conservation. As chief of the Wehrmacht's Economic Warfare Division, Thomas represented German assumptions about fuel quality triumphing over quantity through superior synthetic production, individual resource management, and professional conservation standards that had enabled German military operations despite petroleum scarcity. German fuel production that Thomas understood included meticulous synthetic manufacturing, individual attention to chemical specifications, and systematic quality control that created adequate petroleum through careful engineering and resource optimization. German refineries produced fuel like precision chemical compounds rather than mass-manufactured products, emphasizing technological excellence over production volume through specialized manufacturing approaches that prioritized individual batch perfection. The sophisticated fuel systems that German industry employed included advanced synthetic fuel plants, innovative coal liquefaction facilities, and specialized petroleum processing equipment that represented pinnacle achievements in chemical engineering through systematic development and operational experience. German engineering had solved complex petroleum challenges that produced fuel adequate for military operations through individual excellence and precision manufacturing. Intelligence analysis of Allied fuel production suggested enemy forces remained constrained by conventional petroleum limitations, refining capacity requirements, and supply chain bottlenecks that prevented massive fuel expansion. German logistics planners calculated that Allied fuel production would require decades to exceed German synthetic capabilities while maintaining acceptable petroleum performance standards through traditional refining methods. Strategic doctrine that incorporated German fuel advantages assumed technological superiority would enable continued operational effectiveness through superior synthetic production and systematic conservation training. Democratic armies could allegedly never achieve rapid expansion and quantity-focused fuel approaches while maintaining individual petroleum excellence that characterized German resource management through precision engineering and professional conservation development. Economic calculations performed by German fuel economists revealed Allied petroleum capacity divided between civilian gasoline production and limited military requirements, suggesting resource constraints that prevented total conversion to military fuel manufacturing. Oil allocation and skilled refining technicians appeared insufficient for massive petroleum production programs, requiring specialized chemical engineering and precision manufacturing techniques. Cultural assumptions about American fuel industrial organization suggested inefficient production methods and profit-motivated rather than strategically focused approaches that would prevent systematic military petroleum manufacturing. German logistics ideology characterized democratic industry as wasteful and disorganized compared to German systematic efficiency and specialized fuel technological discipline that prioritized individual resource conservation. Combat statistics from fuel-limited operations seem to validate German assumptions about petroleum effectiveness and conservation advantages over Allied supply-dependent forces worldwide. German military units had achieved remarkable operational success through superior fuel management and systematic conservation training that appeared impossible for fuel-abundant enemy forces to match through quantity alone. Resource philosophy that German logistics forces emphasized included individual fuel excellence, conservation proficiency development, and systematic resource experience accumulation that created efficient military units through rigorous selection and professional advancement. German forces prioritized quality over quantity in both fuel and consumption, reflecting confidence that superior individual management would achieve victory through technological and conservation advantages. Harold Ickes, Secretary of the Interior and Petroleum Administrator for War, walked through the sprawling Texaco refinery facilities observing revolutionary production techniques that would transform fuel manufacturing through industrial mass production methods adapted for military warfare. The Civilian Petroleum Administrator was applying innovative production expertise to sophisticated fuel construction with systematic efficiency that would fundamentally challenge German assumptions about petroleum manufacturing limitations. The aviation gasoline program that American industry developed represented complete departure from traditional fuel manufacturing that emphasized individual chemical processes over systematic mass production for military operations. Aviation fuel design prioritized octane reliability, combustion effectiveness, and assembly line production capability rather than technological sophistication alone, enabling manufacturing rates that completely exceeded German petroleum industrial calculations and strategic planning assumptions. Refinery techniques that American petroleum companies employed included revolutionary chemical production methods, systematically adapted for complex fuel manufacturing through organized workflow, standardized components, and continuous production that eliminated traditional petroleum manufacturing bottlenecks. American industrial experience had created unprecedented manufacturing efficiency that surpassed specialized fuel production through civilian innovation applied to military petroleum engineering. Workforce mobilization supporting fuel production included revolutionary numbers of workers entering precision refining while maintaining comprehensive training programs that created skilled personnel adequate for complex petroleum processing operations. Democratic educational systems produced abundant human resources through competitive instruction, merit-based advancement, and systematic fuel manufacturing skills development that exceeded traditional petroleum production workforce limitations. Supply chain coordination across American fuel manufacturing included specialized crude oil delivery from multiple continental sources, chemical additives from dedicated manufacturers, and thousands of petroleum components from hundreds of suppliers whose production was synchronized through systematic logistics management. Materials coordination exceeded German organizational capabilities through democratic industrial cooperation and competitive resource allocation that enabled unprecedented fuel production rates. Quality control procedures ensured fuel reliability through systematic testing protocols, continuous inspection processes, and rigorous performance validation that maintained petroleum effectiveness while enabling unprecedented mass production rates. American fuel manufacturing had achieved consistent quality through scientific methods rather than traditional individual chemical attention, proving that systematic approaches could maintain petroleum standards while enabling mass production. Innovation acceleration continued throughout fuel development as American engineers continuously improved petroleum specifications while maintaining aggressive production schedules that traditional methods could never sustain. Competitive pressure encouraged rapid advancement that exceeded conventional fuel development cycles while ensuring manufacturing compatibility and sustained production capability that traditional approaches could never achieve. Strategic planning that incorporated massive fuel deployment included comprehensive petroleum tactical doctrine development and operational coordination that would maximize fuel effectiveness across global theaters. American military strategy integrated production advantages into comprehensive campaign planning that assumed virtually unlimited fuel availability and continuous supply capability. Manufacturing excellence that fuel production achieved included combustion reliability, octane performance, and petroleum effectiveness that exceeded traditional fuel development while maintaining mass production compatibility. American industry had proven that systematic manufacturing could produce effective fuel without sacrificing performance, demonstrating democratic advantages in combining adequate technology with industrial abundance through competitive innovation. May 1945. German intelligence documentation of American fuel production revealed supply statistics that challenged every fundamental assumption about petroleum manufacturing and industrial possibility worldwide. American refineries were producing over 500 million gallons of aviation fuel monthly, while maintaining simultaneous production across hundreds of facilities that collectively exceeded total German fuel manufacturing capacity by incomprehensible margins that seemed mathematically impossible. Mathematical analysis that German fuel planners performed revealed American petroleum production approaching 5 billion total gallons since Pearl Harbor, while German fuel production struggled to maintain 500 million gallons across all synthetic plants and facilities. Enemy industrial capabilities had achieved systematic abundance that completely violated traditional assumptions about precision fuel manufacturing complexity and specialized chemical engineering requirements. Statistical verification through multiple intelligence sources confirmed American fuel production that included standardized petroleum products, revolutionary refinery manufacturing, and systematic quality control that enabled mathematically impossible production rates for military fuel. Enemy manufacturing had achieved unprecedented efficiency that exceeded German fuel industrial organization through democratic competitive methods and civilian petroleum expertise applied to military production. Photographic reconnaissance of American refinery facilities revealed production techniques that completely eliminated individual chemical craftsmanship in favor of systematic manufacturing approaches directly adapted from civilian petroleum industry methods for military applications. Democratic fuel industrial organization had achieved military production through competitive, rather than centralized authoritarian methods, and systematic resource optimization. Economic calculations demonstrated American fuel expenditure that exceeded entire German petroleum budgets, while simultaneously maintaining civilian gasoline production and comprehensive international assistance programs. Democratic capitalism had achieved resource abundance that centralized command economy methods could never duplicate through systematic efficiency and competitive innovation in fuel manufacturing that rendered German economic assumptions obsolete. Supply chain analysis revealed American fuel manufacturing coordinated across continental distances with petroleum flows that dramatically exceeded German logistical capabilities and organizational systems. Enemy industrial organization demonstrated systematic coordination that exceeded authoritarian central planning through competitive cooperation and democratic resource allocation methods in fuel production that achieved efficiency through civilian expertise. Technology assessment based on captured American fuel samples revealed manufacturing quality that maintained petroleum effectiveness while being produced in quantities that German industry considered physically impossible without sacrificing performance specifications. Mass production had achieved consistent reliability through systematic scientific methods rather than individual attention and specialized approaches that characterized German fuel manufacturing philosophy. Performance analysis of recovered American petroleum demonstrated that mass production had achieved combustion reliability, octane effectiveness, and fuel performance that proved adequate for warfare while being manufactured at impossible scales. Systematic engineering had proven effective in producing functional fuel through competitive innovation and scientific manufacturing approaches rather than traditional chemical craftsmanship. The statistical impossibility had become undeniable strategic reality that forced German acknowledgement of democratic advantages in fuel industrial organization that exceeded authoritarian alternatives through competitive efficiency and systematic abundance in petroleum production that would fundamentally alter mechanized warfare through energy superiority rather than individual technological excellence. March 1945. The massive Allied mechanized operations across Western Europe revealed devastating effectiveness of American fuel production as over 12,000 tanks and vehicles operated continuously while maintaining petroleum reserves that exceeded German total fuel capacity. The mathematical superiority of American manufacturing had translated into overwhelming operational dominance that rendered German fuel conservation philosophy strategically obsolete through systematic petroleum abundance. Tactical deployment that American fuel abundance enabled included multiple armored divisions operating simultaneously across European theaters while maintaining operational capabilities that German forces could never counter, despite individual tactical superiority and crew training advantages. American production had eliminated traditional fuel constraints through systematic abundance and continuous petroleum supply that exceeded conventional mechanized warfare limitations. German military commanders discovered operational situations where disrupting individual fuel supplies achieved minimal strategic impact because American petroleum reserves exceeded German interdiction capabilities through numerical abundance. Mathematical relationships had shifted decisively toward Allied mechanized forces through fuel capacity rather than individual operational effectiveness or tactical excellence that had characterized traditional mechanized warfare approaches. Combat statistics from sustained European operations documented German fuel shortages that could not support extended operations, while Allied mechanized units maintained operational strength through continuous fuel production and systematic petroleum replacement programs. Fuel abundance had created tactical sustainability that exceeded German response possibilities and resource allocation capabilities through democratic petroleum organization. Intelligence analysis by German logistics commands revealed American fuel capabilities that dramatically exceeded strategic planning assumptions, while demonstrating petroleum organization that surpassed authoritarian efficiency through democratic, competitive methods. Enemy capabilities had achieved systematic advantages that traditional military logistics could not anticipate or counter effectively through conventional fuel conservation tactics. Psychological impact on German military personnel included recognition that individual conservation excellence could not influence strategic outcomes when facing opponents with unlimited fuel capabilities and continuous petroleum reinforcement. Tactical fuel efficiency had become strategically meaningless against American production abundance and systematic petroleum deployment that exceeded traditional mechanized warfare mathematics. Operational advantages that American fuel production provided included petroleum availability, supply replacement, and sustained operational capability that maintained mechanized effectiveness under extended campaigns across multiple theaters. Systematic fuel operations exceeded German capabilities, despite synthetic fuel advantages and theoretically superior conservation coordination. Mobility capabilities that fuel abundance enabled included sustained offensive operations, continuous mechanized support, and operational flexibility that German forces could never counter through individual conservation excellence. American production had created operational sustainability that exceeded traditional fuel limitations through systematic abundance and petroleum adequacy. The fuel-powered Allied advance demonstrated American petroleum production had fundamentally altered mechanized warfare mathematics through fuel capabilities that rendered traditional conservation excellence obsolete when facing systematic abundance combined with adequate performance and continuous petroleum supply capability. May 8, 1945. As Nazi Germany surrendered unconditionally following complete Allied fuel superiority, the final accounting of American petroleum production revealed numbers that had redefined mechanized warfare. Over 5 billion gallons of aviation and motor fuel manufactured through revolutionary refinery methods that averaged 15 million gallons daily at peak production, creating energy capabilities that had overwhelmed German fuel conservation through unprecedented systematic abundance. Strategic validation that American fuel production provided confirmed industrial mobilization as the decisive factor in modern mechanized warfare, while demonstrating democratic advantages in manufacturing organization, resource allocation, and technological application that exceeded totalitarian alternatives through competitive innovation and systematic efficiency optimization. Democratic petroleum industrial organization had proven superior to authoritarian approaches through mathematical evidence that could not be disputed. General Thomas's post-war acknowledgement included recognition that German fuel efficiency had been strategically defeated by American production capabilities that exceeded every calculation of democratic industrial potential and petroleum manufacturing capacity. Mass production manufacturing had rendered individual fuel conservation strategically irrelevant through overwhelming supply superiority and coordinated petroleum deployment that exceeded traditional resource management approaches. Economic efficiency that American fuel production achieved included dramatic cost reduction through volume manufacturing, while maintaining petroleum effectiveness that exceeded traditional fuel development methods. Competitive capitalism had proven systematically superior to command economy organization for sustained fuel production and technological advancement across global operations through democratic resource allocation and competitive innovation processes. International cooperation through American fuel deployment included comprehensive petroleum transfers to Allied forces that enhanced collective operational capabilities while demonstrating American production capacity far beyond domestic requirements. Democratic values had created sustainable assistance through systematic fuel sharing and strategic generosity programs that exceeded traditional military alliance approaches through competitive manufacturing. Technological legacy of American fuel production influenced post-war petroleum industry through revolutionary manufacturing techniques, systematic refining principles, and scientific quality control methods that transformed global fuel production standards. Scientific advancement had created lasting advantages through systematic research and competitive innovation processes that exceeded traditional petroleum approaches through civilian refinery expertise applied to military production. Resource systems that fuel abundance enabled included accelerated operational programs, adequate petroleum availability for training, and systematic fuel development that created energy resources sufficient for expanded military capabilities. American petroleum education had produced fuel personnel through competitive instruction and merit-based advancement that exceeded traditional conservation development approaches. Manufacturing innovation that enabled American fuel success demonstrated democratic society's ability to coordinate massive petroleum resources through systematic planning and competitive efficiency rather than authoritarian control. Democratic systems had produced fuel capabilities that exceeded totalitarian alternatives through systematic coordination, competitive innovation, and merit-based operational advancement that proved democratic advantages. The petroleum triumph had proven that democratic industrial organization could achieve systematic advantages over traditional fuel conservation through competitive innovation, systematic manufacturing, and abundant production that totalitarian fuel systems could never match through centralized control, individual conservation, or authoritarian resource allocation alone in petroleum manufacturing and mechanized warfare. If this incredible story of how American petroleum production overwhelmed German fuel conservation through systematic abundance amazed you, make sure to subscribe for more tales of democratic industrial triumph.